Welcome back. This is in essence part 2 of a 3-part lecture on configuration management, version control. In the last lecture I gave you a general overview of configuration management, version control concepts and motivation. Here I want to dive down and give you an overview once again, although in this case of the Subversion system in particular and the way we're going to use Subversion, which is through Google Project Hosting. So, as I kind of discussed before, Subversion is an example of a centralized configuration management system. And there's a whole lot of stuff that has to do with repository administration when you have a centralized repository. Okay? Clients basically connect to that centralized repository in order to download a working copy of the system that they can play around with, and then they check things back in. So the working copies of the system are just basically directory trees somewhere on your local disk. They're going to contain all of the actual source files for the system, plus some administrative files for Subversion. And those administrative files are always kept in a special subdirectory that is named .svn. They have a dot in front of them because that's kind of a convention for, special metadata files. Okay, so in Subversion, there's, you need to understand what an update is, a commit, and what revisions are. So let's go through them quickly. We're going to talk about the working copy for a system as being a local directory tree on your file system. The process of committing is uploading your working copy to the Subversion system, and if that's successful, there's a new revision of your entire system or the entire repository, but generally there's kind of a one-to-one correspondence between repositories and systems. That represents not just the latest state of your system, but the latest state of the entire set of files in the entire system. Okay, and then you can also do this thing called updating. So committing is uploading stuff. Updating is downloading stuff, and in general you're going to download the entire project at once, or you're going to update the entire project at once, which means that you're going to make your local directory tree, an exact copy of the latest contents of the the repository version of the system. But that's not absolutely necessary. It's possible in Subversion to just update, for example, single directories and not make any changes to other. And it's possible to commit only single directories and not commit the entire contents of your working directory. But for simplicity's sake, I think that the simplest way to start off is just by thinking of committing as saying, I've got my local version of the system. I'm going to commit the whole kit and caboodle up there, and when I do an update, I want to get everything that's up there down here on my local directory so that I can see what's going on. Okay, so just to review, even though we can think of files going through multiple versions, okay, which they do, with respect to Subversion, we always think in terms of what Subversion calls a revision. We actually, in our terminology, think of that as a configuration, because what the Subversion revision numbers are actually configurations or sets of a snapshot of the state of all the files in the system at once. So here's an example of that. Okay. Now, one of the cool things about Subversion is that you can make copies extremely cheaply because they just kind of create pointers rather than actually physically copying the contents. So that means that we can create branches of the current version of the system, or we can tag certain configurations and give them a special name and do all that stuff in a very cheap way in Subversion. And this contrasts actually with CVS, in which it was much harder to do. Okay, so Subversion by convention has a top-level directory called trunk, which is where the main line of a development is going to occur. Branches, where you can create subdirectories which consist of kind of alternative paths of development. So for example, you may decide, oh, I have this experimental feature I want to try to implement. and I'm not sure if it's going to work out. So I'm going to put it in a branch, and besides, I'm going to have to break a bunch of things along the way. So I want the regular development to go along unimpeded while I play around with, my experimental feature. So I might make a copy of the contents of a trunk, on Monday, put it in a branch called, experimental blah, 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 whatever it is that I'm doing, and then work on that for the entire week. And then eventually, if it works out, I might want to merge that branch back into the trunk to represent, to actually update the main line of development to incorporate my new feature. The third directory that's there by convention is called tags, and that's when, let's say you're working, you're making all these configurations, there's, commits, then you get to version 1.0, okay? What you want to do at that point, and that's the version that's going to be released to the, the outside world. People are going to be using it, people are going to be reporting bugs against it. But as we know, every time you make a commit, you make a new version. So there might be 5 or 6, new versions of the system every single day during active development. With the tags directory, you can make a copy of the state of the system at the exact moment in time when you've decided this is the one that's the 1.0 release. Put it in that directory, and then when bugs are reported, you can always easily find that tagged version of the system, check that into your local workspace, and play around with it to figure out what's wrong and whether that bug has actually been fixed in some later update or whatever. So here's an example. We have this this stack system with a trunk, tags, and branches directory with various subdirectories representing what's going on. Okay, so as I said before, the trunk is generally like the gold version. In our case, it should always compile, it should always pass its test, it should always pass the verify target. Okay, that's the way you do development most efficiently in this class. You're going to learn it. Some of you will learn it sooner, some of you will learn it later, some of you will never learn it, unfortunately. Okay, the best thing to do when you're working with other people is get verify to pass right away and keep it passing all the time. Okay. If you do that, then in some sense, it's very easy. You can turn in the system at any point in time, and it's going to compile, it's going to have tests, it's not going to fail check style, and so forth. Branches, we probably won't do too much in this particular class, but as I said before, they represent temporary, development, projects which you want to keep isolated from the main line of development. And you may, I guess, you may not have it pass verify for some period of time, although I'm not quite sure why one would do that, really. From having used this, build system for many, many, many years, I've learned through painful experience that even when you're doing experimental stuff, you should just always write to pass these quality assurance checks. It doesn't ever really slow you down. It just finds errors earlier. And it's always more painful to fix 150 check style errors, later. You'd rather fix 1 or 2 at a time as just part of the development process. And so you merge these branches back into the trunk when you want to. I think in this class, you probably won't create any branches. You'll just probably always work in the trunk directory. So, as I said before, setting up a Subversion server is kind of complicated. And fortunately for this class, there's a freely available server that we can use. It's hosted by Google and its Google Project Hosting service. Not only has a Subversion server, but they have mailing lists, issue tracker, other kinds of stuff. There are alternatives to Google. There's SourceForge, there's GitHub, there's even other options like Heroku and so forth. But for this class, Google Project Hosting has a nice kind of combination of features. It's in many ways one of the simpler project hosting services to use. It requires the least amount of kind of complexity to get going with, and I think that's a feature in this class. Once you understand Google Project Hosting and are comfortable with it, moving to these other cloud-based hosting services is quite simple. You'll need a local Subversion client. There's the Tortoise SVN client program that when I had a Windows machine, I used it. It's a very, very nice piece of software. So I'd really recommend that if you're using Windows. If you're using the Macintosh or Linux, there's this program called Smart SVN. Not quite as good as Tortoise SVN, I have to say. It's hard for me to admit that there's some Windows software that's better than the software available for other platforms, but in this case I got to call a spade a spade. Okay, so you can go to Google Project Hosting, do a little reading about it. I've got some links for you. And there's kind of three basic use cases that you have to worry about: is downloading the sources for a project, making a change, and then when you start up a new project. So to download a project, you just need its URL. If you want to be able to commit your changes to the project, as opposed to just read the sources and fool around with them, then you have to become a member of the project. So the project administrator has to add you as a committer, and you have to then figure out the Subversion, your Subversion password in Google Project Hosting. Then you check out the trunk to your local computer. If you're doing commit access, which is what you'll be doing in this class all the time, you'll use the HTTPS URL for commit access. And I'll in the kind of the third part of this lecture series, I'll show you how that works. So here's the basic workflow. You'll use Subversion. You'll use SVN update to make your local workspace consistent with whatever's in the repository. The stuff that your friends have been working on. You'll run the verify target first thing to make sure that you're starting with a working version of the system. Okay, that's just good as a sanity check. Okay, that way later on when you run verify and something breaks, you'll know it was stuff that you did as opposed to stuff that was already in there when you got it. Okay, then you'll make your changes, you'll run verify again, make sure that you get rid of any errors that occur, and then you'll commit those changes. So it's very, very simple. Okay, download the version of the system, make sure it works, make your changes, make sure it works, upload it back to the repository. Create a new project, not that much harder. You have to define the new project, add the initial members. Optional thing you can do is set up a discussion list in Google Groups. Find your Subversion password, which is located in the settings for the for your account. Then you have to populate the Subversion repository, which is the easiest way I found to do that is to check out the trunk directory, which is empty, of the your newly created Google Project Hosting project. Check out the empty trunk directory to a newly created local directory. Add your initial set of project files to that directory. Then use the svn add command to make those files, put those files under version control, and then commit those files. Okay, so in Subversion, it's not the case that simply putting things in a directory automatically puts it under version control. You have to use this explicit add command to make that happen. There's a lot of other things, branching, SVN blame, switching between the various, subdirectories of a repository. Those are easy to understand later on once you get past the basic usage, so we won't cover them right now. Okay, thanks a lot.